Hello students, welcome back to Chemistry Online class brought to you by Hayota Virtual Learning Platform. I am still your chemistry tutor, Olabisi Olaweye. Today, we are looking at a topic which is laws of chemical combination. And at the end of this class, you're expected to be able to state the laws and also prove the laws and apply to treat some questions after the class. So I will advise you to wait and participate, pay attention to the theory so that when you are treating the revision aspect, you will understand it. The revision aspect of this class contains questions carefully selected from the Waec past questions under this topic. So back to the laws of chemical combination. There are 3 laws of chemical combinations which describe the general features of a chemical change in a chemical reaction. And these laws are the major, they make up the foundation of chemical equations and chemical formulas. The first one here is the laws of conservation of mass. The second one is the laws of constant composition, which also means definite proportion. And the third one is the laws of multiple proportion. So what's the law of conservation of mass or matter? This law is actually trying to explain that matter is neither created nor destroyed during a chemical reaction, but that it can change from one form to another. That is, during a chemical reaction, we usually have 2 materials reacting together to form reactants. And when these 2 reactants react together, they form product. So on the reactant side and on the product side, the 2 sides must be equal. That is, the mass of the reactant must be equal to the mass of the product to be able to prove this law that matter is neither created nor destroyed during a chemical reaction. That is, as the reaction is occurring, nothing was destroyed, nothing escaped. And the total mass at the beginning is equal to the total mass at the end, provided the reaction takes place in a closed container and none of the products escaped. This is the basis for the law of conservation of mass. That is, mass was conserved. None of the mass was lost. Now, this principle law can be described using an experiment, which is represented with a diagram here. You can see here that this is a test tube inside a conical flask, and 2 reactants will react together. This is a weighing balance. Before the reactants react together, you can see that this is a string, like a rope, holding the test tube that contains silver trioxonitrate 5. And then inside the conical flask is a solution of sodium chloride. The 2 has not mixed together. Now the apparatus are intact, so the weight was taken before the experiment. Then after the experiment, you can see here now that the thread was pulled. Pull the string. After pulling the string, you will see that the test tube, you know that this a cork has been attached to it, to this one, to make it airtight so that nothing will escape. The cork is still intact here. Then the test tube, after pulling the string, the solution in the test tube pour inside that of sodium chloride. That is, the silver trioxonitrate 5 and the sodium chloride mixes together. They react together, and the weight is also being taken without anything escaping. And it was found out that at the end of the experiment, both the mass at the beginning was also equal to the mass at the end. So that is the formation of white precipitate, and the formation of white precipitate occurred. That is between silver trioxonitrate 5 and sodium chloride. we ended up having silver chloride and sodium trioxonitrate 5 being formed. This is a white precipitate to show that a chemical reaction has occurred and through a color change, because this will form white. So this is to justify the law of conservation of mass. And we have a simple calculation under this. That is a mixture of 12 grams of carbon and 64 grams of sulfur is heated until reaction is complete, and none of the reactant is left over. What mass of the compound carbon 2 sulfide is formed? That is, when carbon and sulfur react together, carbon 2 sulfide will be formed. And the question is, what is the mass of the compound that is formed? Now, the mass of the compound will definitely be the mass of the reactant. At the beginning of the reaction, the mass of carbon used was 12, the mass of sulfur 64. Now, by the law of conservation of mass of reactants will be equal to the mass of product. So the two reactants here are carbon and sulfur. So 12 plus 64 definitely will give us 76 grams, which is the mass of the product. It should definitely be the mass of the product, since none of the reactants escaped. The next one here is the law of definite proportions. And the law of definite proportions states that this law of definite proportion actually also means the law of constant composition. That is, the composition of a compound, whether in Lagos here or in UK, the composition always constant. The law of, and is also known as definite proportion. The law of definite proportion states that all pure samples of a particular chemical compound contain similar elements. That is, provided the samples are pure and in any location they all contain similar elements combined in the same proportion by mass. Please take time to study this. Now, look at this setup. We can see a conical flask here. Zinc and hydrochloric acid is inside, and the essence of reacting zinc and hydrochloric acid together is to form hydrogen. And what is the function of the hydrogen? To form zinc chloride and hydrogen gas. The hydrogen gas produced when zinc and hydrochloric acid react together here, it will be passed through this delivery tube to a U-tube where fused calcium chloride is there. The fused calcium chloride is acting as a drying agent to dry the hydrogen. And what is really happening? What do we want to test? We want to test two different samples of the same compound, like copper 2 oxide of two different samples, sample A, sample B, that was got from different sources. The first source could be from copper trioxonitrate 5. When it is heated strongly, we can get copper oxide. We can also get copper oxide when copper reacts with trioxonitrate 5 acid. These two, when heated, can give us copper 2 oxide, and this copper 2 oxide could be placed inside a desiccator where it is dried, and then it is inside this container. Now, these are hard glass. After being dried, it is placed in a hard glass in two different containers, sample A, sample B of copper 2 oxide. And don't forget here, I said we're going to pass hydrogen, and hydrogen here will be produced from zinc and hydrochloric acid, which reacted together. Hydrogen passes here, is dried here, so we have dry hydrogen passing through this place to mate the sample, which is being heated. Because that's why you have this as a hard glass. Now, don't forget that its sample contains the same compound but different samples. So the dry hydrogen is passing through this sample for reduction purpose. It's going to reduce the reactions, and when the reduction occurs, reduction actually is the removal of oxygen, while oxidation is the addition of oxygen. So from the copper 2 oxide, when it reacts with hydrogen, hydrogen here removes the oxygen to form water. So the water comes out here in form of steam, and then the steam is also dried using fused calcium chloride. So we have just pure sample. You don't forget that heating is also taking place here, so we have pure sample of copper in the two cases. So How do we prove this law? 2.5 gram of one sample A of copper 2 oxide when completely reduced gave 2.02 gram of copper. Another compound, 2.30 gram of another sample B of the same oxide, that's copper 2 oxide, prepared by a different method, when reduced, gave 1.86 gram of copper. Using this data, illustrate the law of definite proportion or constant composition, that is, all pure samples of the same compound contains the same proportion, contains similar elements combined in the same proportion by mass, meaning that we have copper 2 produced from different sources here. This is a mass of copper 2 oxide, 2.50 in sample A, the mass of copper 2 oxide in sample B. Now, after reduction took place and heating, the copper 2 oxide was reduced with hydrogen and the only pure copper remained. That's a pure residue, copper residue. Under sample A, we have 2.02 gram left, and under sample B, we have 1.84 gram left. Now, how do we get the percentage of copper in each of the sample? This is simply by calculating the percentage of 2.02 over the total sample multiplied by 100. While in sample B, we also have 1.84, which is the mass of the pure copper over the mass of everything, or the sample, multiplied by 100. You will notice that in each cases, we have almost the same answer. So this is 80.1 and this is 80, which is roughly equal to each other, supporting the law that says that all pure samples of a particular chemical compound contain similar elements combined in the same proportion by mass. This is a law of definite proportion or constant composition, that is, anywhere, no matter the source of production, all pure samples of the same compound contains similar elements combined in the same proportion by mass. You can see here we have 80.8 and we have 80, almost the same. The last law here is the law of multiple proportion. And the law of multiple proportion states that if two elements combine together to form more than one compound, for instance, if copper and oxygen again combine together to form compound copper 1, that's and copper 2. This is copper 1, and this is copper 2. Now, the reason I call this copper 1 is because if you have +1 here and oxygen carries -2, exchange the valency, you have Cu2O. While here, if you have copper 2, 2 here, oxygen is also 2, they cancel out, you have CuO. So CuO here is copper 2, while Cu2O is copper 1. Now, the law of multiple proportion says that if two elements combine to form more than one compound, the different masses of one, which combines with a fixed mass of the other, are in a simple whole number ratio. That is, the two different samples containing the same element but in different proportion or different masses are always in a simple whole number ratio. We can prove this by working out this. Two oxides of a metal contain 30% and 22.2% of oxygen. Oxides of a metal here that we are referring to here is, for instance, copper. So we have copper 1, we have copper 2 oxide, copper 1 oxide, two different compounds to form more than one compound. Show that this oxide obey the law of multiple proportion, that is, they have different proportion, and they are always in a simple whole number ratio. So in sample 1, how do we get the mass of oxygen? The mass of the oxygen, because they said two oxide of a metal contain this and this of oxygen. So mass of oxygen in sample 1 is 30. Mass of oxygen in sample 2 is 22.2. So how do we get the mass of the metal itself? Take away 30 from 100, we have 70 for the metal here, which could be copper, and this is for oxygen. To get this, you also take away 22.2 from 100, we have 77.8 for the copper. So how do we prove that this supports the law of multiple proportion? If 30 grams of oxygen is combined with 70 grams of the metal, in this case, that's 30 grams of oxygen combined with 70 grams of the metal, and 22.2 grams of oxygen is combined with 77.8 grams of metal, what will 1 gram combine with? You have 30 gram combining with 70. So 1 gram of oxygen will combine with what? With X. So cross multiplying, we have 1 gram multiplying 70 is equal to 30 multiplying X. And so you have to divide both sides by 30. So you have 1 times 17 over 30, which gives us 2.3. And on the other hand, if you do the same, if 22.2 gram of oxygen is combined with 77.8 gram of metal, 1 gram of oxygen will combine with what? So we have 1 gram multiplying 77.8 and 22.2 gram multiplying X. So when this happens, we have 1 times 77.8 divided by 22.2. This is a simple arrangement. 30 gram for 70, 1 gram for X, cross multiply. 22.2 gram for 77.8, 1 gram for X, cross multiply. So from here we have to multiply 1 and 77.8, then divide both sides by 22.2. So the answer here is also 3.5. You can see that this is 2.3 and this is 3.5, meaning that they are in a simple whole number ratio. 2.3, 3.5. The whole number ratio is as simple as anything. If two elements combine to form more than one compound, the different masses of one which combine with a fixed mass of the other are in a simple whole number ratio. That supports the law of multiple proportion. So we are moving on to the aspect of revision question. I will show you the question now. I'm going to pause the video, show you the question, and then we'll come back to solve it. Hello students, welcome back to the revision question class on laws of chemical combination as promised. So these are the questions to be treated on this topic, and they are extracted from Waec questions. I have like 5 of these questions to be treated under chemical combination. Okay, there are 4 in numbers extracted from different years. So you are expected to treat these questions, after which we come back to solve it. Hello, welcome back to the revision questions class on chemical combination, and this is time to solve the questions. Now I want you to take time to reflect back on what you've learned under the theory. This question here is June 12, 2012, number 2B, option 2, subsection 2. A metal M forms 2 oxides containing 11.1% and 20% of oxygen. Show that these figures agree with the law of multiple proportion, which says that the law of multiple proportion actually says that when an element combines to form more than one compound, the variable state of one which combine with a fixed state of another one are in a simple whole number ratio. And so we are going to use this calculation to prove or support the law of multiple proportion. Now from this question, a metal M forms 2 oxides, 2 different oxides containing 11.1 and 20% of oxygen. That is, the first sample contain 11.1%, and the second sample sample B contains 20% of oxygen. So if that is the case, and if the metal combined with oxygen, you have metallic oxide. So it means the total mass of the oxide is 100, while that of oxygen is 11.1. If that is the case, the mass of metal is what? The mass of metal in this case is therefore 88.9%, subtracting 11.1 from 100, while here it is 80%. So how do we get the proportion? Now, if 11.1 of oxygen combined with 88.9 metal, 1 gram of oxygen will combine with what? The same thing here. If 20% of oxygen combine with 80 of metal, 1 gram of oxygen will combine with what? Cross multiplying this, we have 11.1 multiplied by x equals to 1 multiplied by 88.9. Dividing both sides by 1, 11.1. And here too, 20 multiplied by x equals to 1 multiplied by 80. So dividing both sides by 20, we have 4 here, and we have 8 gram here. So we can see here that sample A actually contains 8 gram, while that of B contains 4. You can see that these are in what? A kind of multiple proportion, like simple whole number ratio, ratio 2 to 1, and they are multiple. The first one is a multiple of the second one. So this calculation actually back up the law of multiple proportion. And that leads us to the second question. A metal M forms 2 types of chlorine, MCl2 and MCl3. Which of the following laws best explain the relationship between the chlorides? Look at this. M is fixed, while chlorine is changing, Cl2, Cl3, and these are in simple whole number ratio. Unlike law of constant composition that only talk about the composition of the metal in the different samples, that they have almost the same mass, irrespective of where they are made or their sources. That is for the law of constant composition or definite proportion. And for the law of conservation of mass, that one only deals with the equality in the mass of reactant and the mass of product, to show that matter is neither created nor destroyed. And so from what you have here, we can see 2 different ratio 2 to 3, which are simple and simple whole number ratio. So the best answer here is the law of multiple proportion, because we are dealing with the mass of the chlorine there that is changing. So this is supporting the law of multiple proportion, excuse me, which is C. And the next question here is, the law of definite proportions states that pure samples of the same compound contain the same element combined the same proportion by mass. Which one is the correct option? Pure samples of substances are in the same proportion by mass. Then chemical compounds are pure because they contain the same elements. Then D, matter can neither be created nor destroyed. That is why June 2018, number 40. The best answer here is option A, which states that pure samples of the same compound contain the same element combined the same proportion by mass. This is the law of definite proportion. I want you to take time to also learn this. The last question is stoichiometry. Stoichiometry is based on the law of what? Now, actually, stoichiometry has to do with the features of a chemical equation, the reactants and the products, the number of moles, their states, then the equality in the products and reactants formed. So when you want to know everything about an equation, the number of moles there, whether the equation is balanced or not, you want to know more, and the result of that equation, it has to do with stoichiometry, and that is under law of conservation of mass, which says that matter can neither be created nor destroyed, because it reflects that the total number of reactants must be equal to the total number of products, provided the container is closed during the reaction, to back up the law that states that matter can neither be created nor destroyed. And so the best answer here is T. That is from Waec 2019, number 12. I want you to treat more questions on this topic. Search your past questions, treat more questions, and I wish you all the best as you prepare for your exam.